instrumentation. People also recognize it as process control and industrial automation. Okay, so there are different abbreviations of the couple of words. People use it as a synonyms. In industry, very popular term is C&I. They simply called it control and instrumentation. If you say control, it's a separate domain. If you say instrumentation, it's a separate specialization. When you say C&I, it's a very popular term, or you can say that our industry standard, irrespective of the country, application area, type of application, type of industries, they use a common term that is called C&I. Clear? And whenever we use this term C&I, obviously there are two specializations participating, so it's very obvious that one will be a front end, one will be a back end. Yes or no? Eh? You have a soccer team. You means not you. Country has a soccer team. Some people will play forward. They may be striker. They may be forward. Everybody is forward. Somebody needs to defend also your own post. So we can't say that the defense is the secondary, striker is the first. Everybody has their own role. Okay, but they are playing as a team. So when you say C&I, now C&I is a team. Okay, so now we want to decide that which one will be the front end, which one will be the back end. How would you decide? How would you decide? Yes. Let me take an example of your smartphone. There is an automatic brightness resolution control has already come with the factory setup. Okay. Do we follow all the time factory setup? May or may not, because you are an end user. You are a owner of your device. So if you want, you can change it or not. Right now. So to do that, what do you need? Panel. Your display unit, what we say called screen, and through screen we should have access to interface with certain parameters that I can regulate. Right now, so that means you should have a control command in your hand. Otherwise, you can't do it. Yes. So now in this scenario, which is control? I mean, which is more important, control feature or the display? Both are important. Okay, so don't be diplomatic, but which one is more vital? Control. Okay, so which one you want to keep front end? Control. Is this means that the display is less important? No, but someone will be in back end. Understand? So from this example you understand, whenever either you can put control as a front end or you can use control as a back end. Whenever industry application comes, control is always a back end. Okay? Instrumentation is the front end. Other than this, industry application. I mean, now if I say that you can automate a defense vehicle, right? You can automate an industry whose end objective is to produce or manufacture or fabricate some finished product. You can automate medical appliances also. You can automate scientific experiments also. Correct? As I say scientific, probably it may not be fully manual. Understand? So the industry application is the only sector, or you can say is the exception sector, where control is always a back end, because it has to execute all the field tasks silently. Correct? What you see, the industry or machines are running and are dictated by some digital controller that you say that it acts as a brain of the automation system, and you do not have a direct access to that control. Rather, as an operator or as an engineer, 24/7 if you are working in an industry, you normally see those big screens, what we call HMI, human machine interface, right? So primarily your monitoring system, I can say in a simpler word. Correct? Clear? So through this monitoring system, okay, primarily in overall term we called it automation. Other than the controller, everything else is the instrumentation, that those things are available to you in front of your screen on a virtual mode. Correct? So through those screen, it doesn't matter you have a power station or you are in any steel industry or whatever is, whatever type of your control mechanism is, whether it's a SCADA or DCS, doesn't matter, but you have a certain access through those screens, through those display panels, through those monitoring system, by which you are not only able to monitor those parameters, okay, those finished product is being manufactured on a real time basis, but if needed, you can also regulate those parameters through the HMI, or you can say that by commanding to controller. Are you getting my point? So because you are a system planner, you are an executive engineer, you are the operator, so therefore you keep, human being kept itself at the highest hierarchy. Get it? Then the next hierarchy is the controller. I am talking about the hierarchy of automation. Clear? So among human machine interface, human is told the highest hierarchy. Next is controller. One will dictate the machine, and the lowest is the machine, which is supposed to be controlled. Getting my point? Now when I say controller, this controller is incomplete until unless those informations are available to you on a real time. Then you cannot be able to visualize. Maybe controller is working fine, okay, but you do not have those information access. So that's why even among the controller and HMI is kept at higher hierarchy. Understand? Because you are supervising. Then the hierarchical control action comes. Are you getting my point? So if you will distinguish it further, we can say that human has the highest hierarchy. Clear? Then your automation system comes into the picture. Out of automation, the HMI has the next hierarchy. Okay, maybe hierarchy 2A you can say. 2B will be the controller. Clear? And then the controller will do the rest of the job based on your pre-phased algorithm. It will take a decision. It will dictate particular actuation system to act upon it. Actuator will respond to the controller's action, and accordingly your machines will react. Once your machines react, accordingly based on your pre-phased parameters again, you will get a finished product. Okay? So your machines which is supposed to be operated is kept at the lowest hierarchy. Idea is very clear? Clear? So there should not be any confusion if tomorrow you are reading a term instrumentation and control in place of control and instrumentation. Clear? INC more than like academic term, very widely utilized in academics. C&I is more popular acceptable term in industry. Both possesses the same meaning. Whenever these two terms will come together, instrumentation will be always a front end, control will be a back end. Except this scenario, in rest all applications, control will be always a front end, instrumentation will be a back end. Okay? The first command is always given to the control action. Getting my point? Why so? Why so? These industry people are so great, or what about it? Any reason? Bolo. When everywhere we kept control as a front end, why in industry application we keep it as a back end? Let us go back to your smartphone. Who is the user? Themselves, right? You are the user, no? We are the users, right? So, who needs the command to control the device as per his or her wish? Yourself, right? Where the control actions are embedded, what kind of control it is? Example of embedded control. Control system can be classified in so many ways. Okay, you might have studied linear control system. You will study non-linear control also, adaptive control, optimal control. Okay, nowadays we call it intelligent control. Get it? Right? So, out of these, as far as this smart device is concerned, your smartwatch, your smartphone, or whatever it is, kind of smart device we have. Clear? Even this is smart panel. Okay, this is not a simple display. If you want, I can write something. Okay, and it can respond to me. Clear? I can virtually log it also. So that means it's not a normal display panel. Likewise, it is available in case of at my home a simple TV panel. Okay, that can be converted into a smart panel, no problem. But you need some additional interface. Clear? Right? So in that particular scenario, that is one way of classification. Another way, like you heard about the embedded control, embedded system. Okay, this smart device has some kind of processors or not. Consider home appliances. It has a certain kind of microcontroller is embedded into it or not. Yes. Why we embed these microcontrollers or microprocessors? Why? Because you need a digital processor who can take certain decisions based on your input. It's like a semi-automated platform, and based on your given inputs, that embedded platform will take certain decisions, and accordingly, at that instant of time, that controller will command the rest of the system, the machines, to act upon it. Correct? Yeah? So that microcontroller has to be embedded inside that device or not? Yes? So because that microcontroller or processor is embedded inside the device, into the device, so it is an example of embedded control. Idea is clear? Now let us assume, consider the plant or factory where the same smartphone has been manufactured. It's fabricated. Finally, is assembling of multiple units. Okay? So is fabricated. Done? Now there you also require some control mechanisms. Yeah? Do you want a separate control mechanism each time you are going to fabricate a phone? Necessary? No. Because the similar model, until unless you are not going to change the specifications, the amount of effort needed to put by the automation for one piece or 1,000 pieces is the same. For 1,000 pieces, it's the repetition of 1,000 times of the same algorithm. Yeah. So there you should have a dedicated assembly line. Okay. And every step of assembly line is commanded by certain prefaced algorithms. Accordingly, either human, or if it is a fully automated system, then your robots will act upon it. Finally, you are getting a finished smart phone. Am I correct? Okay. So you are using a control mechanism which is interfaced on the embedded line, assembly line, and the assembly line, if you are giving some input, at the end you are giving you, I mean in return it is providing you a finished smartphone, a new one. Correct? And the same process can be repeated again and again. This is an example of process control. You are trying to control a process. You are trying to control some certain steps of execution, certain steps of command. Okay? Is it? So when you are applying the control mechanism in an industry, that is the example of process control. When you are applying inside a device, then that is the example of embedded control. Idea is clear? Process doesn't mean that it is always related to some mechanical industries where the mechanical engineering has a role or the chemical engineering has a role. Okay? Correct. Clear? Why earlier those words were not connected? Because nobody thought 40 years back that you will have a kind of a smart device through which you can play the different roles. That is my point. This is something what we are experiencing in past 10-15 years, roughly around decades of time. Clear? So that is the process. So that's why you need a very clear-cut definition. What can be a process? It can be a series of actions or steps, whatever you can say. Here, taken in a particular order. For what? To achieve or to execute a particular task. Okay? That task can be a manufacturing of a rail in Rourkela steel plant. That task can be fabrication of a smartphone. That task can be of fabricating a smart watch. That task can be fabricating a pair of glasses. Right? Okay? So it can be action, you can say it can be a certain task. Now I'll come across one of very important term. So this approach is clear, front end, back end. Any confusion? Now there is something written live zero and non-live zero standards. Anybody has pen? No. Not pen, this thing. Okay, next time I will try. Now live zero standard and non-live zero standard, what is it? You want to communicate a data, correct? How will you communicate? So first of all, idea is clear. You have a HMI, human machine interface. One end of HMI is the operator or system engineer. Clear? The difference between the two is that operator is responsible to run the show for 8 hours, shift change, another guy will come, take over the responsibility. Okay? And those assigned responsibilities are normally pre-assigned. Until unless some troubleshooting you need to do or some malfunction experienced by the system. System engineer is more or less like an executive, where probably two people among of you is going to join and play that kind of thing. Okay? Now you have little more critical responsibilities. If needed, you are going to run the show. Clear? That means you can supersede the operator and you can command him. You will have some additional access to open the, log in the system and directly command to the controller. Because right now what controller is doing, it is running based on your pre-fetched algorithm. Getting my point? So as I say in other day, that probably you are in a, let's say in the steel industry, and its objective was to overall produce 5 million ton of steel in a month. That is their goal. Clear? Suddenly, the Steel Authority of India Limited or maybe Jindal, whichever the company is. Okay. So the authority has got the additional order of 2 additional millions of ton. Clear? Within the same physical year or maybe within the same month. Whatever capacity you assume. Let's say if you assume 5 million ton in a month, so let us take it 5 million ton, you are getting an order of 2 additional million. Right? Now what do you think? That within the span of a year, forget about a month, even within the span of a year, if you need to increase the capacity by 2 more million tons, so in percent how much it is? Percent? 40% of the additional capacity? Sorry, of the existing capacity? Correct? You have to increase. You need time. So you can't think of just to set another assembly line and then producing it. Okay? This is something you can do that if the target year is 2 years, 3 years, 5 years. But if within the same year you need to supply that, what do you will do? Assuming that you have a capacity to produce 7 million. Okay? Running one additional line is management wish, but with the existing assembly line, you have a potential to manufacture additional 2 million ton. And not only that, and your automation system is already equipped with that facilities. Remember, because you are not going to do all this task manually. Clear? Now, your automation system, earlier your controller was to take care of 5 million ton in a year, right? Now you are asking them to do additional job. So when you are producing 5 million ton, remember your reference is something. Now your reference is changed or not? In a layman language. My reference was 5 million ton, now it is 7. So it is going up. So do you think that the existing preset values of the automation will work? Will work for 5 million ton, not for 2 additional million. That means you need to change. So if you are changing your reference, don't you think that your feedback will also change? Your process value will also change? Your final control variable will also change? Okay? Who will do this job? that system engineer or executive will do that. Okay, so for that you have a special command or access of that controller here. So you will log in there, changes those algorithms, or you can say that upgrade those algorithms. Yeah. Then after upgrading those algorithms, what he will do? Upload or download? Please participate and listen very carefully, otherwise you will confuse. Okay, it's a very interesting subject. Probably most of the things you don't require to memorize. Because don't require to memorize, that's why it's interesting subject. Okay. Ajay, say you email me something. I'd say that, okay, yeah, you just send me that attachment. So what you will do? You will open your email, then attach the file, okay, or photo, whatever the data is, you will upload it, or download, upload, and then you email me. What I will do at my end, I'll download. So there, what we will do? System engineer has opened the controller, changed the reset the algorithms, I would say, taken the necessary steps. If needed, it has to add certain additional algorithms also, if the thing was not fully ready. If thing is fully ready, then you have to preset certain parameters, reset again certain parameters. Once it is fixed, okay, now you can, now the system engineer can move from edit mode to run mode, because industry will run at run mode. Automation by default run at run mode. Okay, you have take it on a manual mode, edit it, understand? Now you have to reburn those algorithms or not? It's a firmware, na? Software को किसके ऊपर करोगे? Execute करोगे ना hardware के ऊपर. So you have to burn it. Again the command. Okay, these are the typical technical language. Okay, so don't be surprised so much. Okay, so you have to burn those algorithms, right? Clear? So now when I say burn these algorithms, basically system engineer downloading it or uploading it? Okay, I repeat again. I said the three steps, primarily. Human is at the highest hierarchy, then the controller was there, then the machine is there. Controller, if I want to segment in two stages, so within the white box I kept HFT, hierarchy, because human is somewhere here. So the control panels, I said that monitoring and control panels is at hierarchy, then the controller, this box is closed, and then the next hierarchy is machine, right? So hierarchy number 1 is human, 2 is control and automation platform. So in a simpler word can be the CNI. So CNI is there, then the operation is there. Machines are there. Machines are there for what? Operation. So the operation is there. Idea is clear? Now tell me, your executive is somewhere, hierarchy 1, controller is at 2. So controller is at the lower hierarchy or higher hierarchy of the human? Lower hierarchy. So where you are programming? Hierarchy number 1. For whom? Controller. One who is lower in the domain. So you will burn the program. So now burning is, you will download the program. Clear? New thing? This was only so true. Okay? You will download the program. Get it? Get it? Now whenever your sensors, those are mounted in the field. Okay, if it is a pressure sensor, it will measure pressure. If it is a temperature sensor, it will measure the temperature. Right? If it is a force sensor, it will measure the force or pressure or displacement out of 3, 1. Okay? And depending on that, either it will differentiate or integrate, and it will give you the data in your form. Okay? Now remember, those sensors are at the higher hierarchy or the lower hierarchy as compared to the system engineer or human machine interface. Lower the hierarchy. So they will upload the data or download the data. They will upload. Getting my point? Getting my point? Any confusion here? Okay. If you are still confused, take an example of your internet. In internet service, what you do? Let me take that example again. You have open an email, compose a mail, attach a file, right? And then you said that I attached it, that means I uploaded and email. Correct? Okay. Right now you are at the higher hierarchy or the lower hierarchy? Then who is that hierarchy? Hmm? One who owns the internet service, right? Right? Simpler word we can say in a layman language, internet service provider. That organization is at the hierarchy. Okay? So it doesn't matter whether I send the data to you or you send the data to me. We both are the end users. So we both are at the same hierarchy. And you are using a service provider. So service provider is at hierarchy. So that's why you are uploading it. Idea is clear? Right? But the same person, once you enter into the role, into the industry, you are an executive. Right? You are executive, that means you are at the higher hierarchy. Okay? Now the controller is at the lower hierarchy. Right? Overall HMI I must say, or C&I is at the lower hierarchy. Lower than you, but higher than the machine which is supposed to be controlled. Getting my point? So that's why now whenever you are running a command at that area, in industrial automation environment, you are always uploading the data. So downloading the data. Idea is clear? Good. Okay, control system all is about known. Process control. Process control can be distinguished in the form of continuous and discrete. Can be. Process control application can it be classified as a discrete and continuous mode? Can it? Depends that how you are measuring those parameters, right? And how the controller is commanding the machine. Okay? Normally, in commercial life or in our day-to-day life, the controllers you are using all are digital controllers. True? Doesn't matter here in your laptop or wherever you see. All are the some or other kind of digital controllers. Okay? Now controller is again a very open term. Very specifically, depending on the application, you can check that whether you have embedded a microprocessor or a microcontroller. Okay, and if it is a need to process huge amount of data, then probably your microprocessor is also insufficient. Then probably in that case you will go for data processors. Normally you call DSP. DSP, remember, abbreviation is also used for digital signal processing. It is also used for digital signal processing. Okay, so I talk about processors. Okay, so probably one DSP can do maybe hundreds of microprocessors. Done? But doesn't matter. Depends that what kind of volume of data you have to deal at the end of the day. But these all are digital in nature. Getting my point? So likewise, I have been told you the other day. So for example, your meteorological department, their job is to forecast the weather and the different parameters of the weather. Okay? Nationwide, state-wide. Okay? Nowadays, even for a small location, macro level of location, like some district-wise, not exactly district, the group of districts. Okay? They forecast for that also. Correct? So it doesn't matter nationwide or doesn't matter the district-wise. Obviously, the district-wise is more challenging task as compared to the nationwide or the reverse. You want to forecast the weather condition of an entire Odisha state, and you want to forecast for Sambalpur district. Which one will be more challenging? Sambalpur, small area. नहीं कंट्रोल कर पाओगे हैं? इजी नहीं होगा. Which one is easy to travel? To go touch one point, one end to another end of Sambalpur district, or one end to another end of Odisha state? संबलपुर ना. then पर संबलपुर इजी होना चाहिए ना? नहीं नहीं क्यों? If your geographical area is confining, ultimately your resolution requirement is increasing meaningfully. Right na? Right na? So if the resolution requirement is increasing manifold times, you need to process even more heavily. Maybe again 10⁶ times faster than that of the at the rate when you are processing for a Odisha state. Clear? Now don't take 10⁶ as a reference. So ultimately motto to say that you have to attain a very highest, relatively highest. Understand? So that's why the prediction of a smaller geographical area is very difficult. Of a nationwide itself a tough job, because it again depends on so many analogous parameters. So there you require analog computers. Okay? So it's a simple. If the input-output mechanism you are dealing in a continuous mode, then it is process control is of continuous action. If it is discrete type, then it is discrete action. What do you think? That in industry, which one will be needed? Continuous or discrete? Or both? What do you think? Say continuous. One answer is continuous. Any other opinion? Any other opinion? This block is clear to all of us? Okay. Where the controller is there? Before the plant. And between controller and plant, some actuation system is there. Okay? So that electrical signal can be converted into non-electrical form. Broadly I am saying, maybe a displacement, maybe something, I do not know, whatever your requirement is. Okay? Maybe opening and closing of the valve, maybe continuously regulating a valve. Now continuous regulation of valve is a continuous signal or discrete signal. It has a more than 2 state. Yes or no? Yes? So can I say that 2⁶ seems like a continuous as compared to 2⁵ or 2⁵. 2⁵ is binary state. On or off. Can I treat it as an open and close of the valve? Either I want to close the valve or I want to open the valve. In between, don't care. So can it be controlled using a discrete signal? Possible. But if I want to continuously regulate a valve, then depending on requirement, you want to increase the rate of flow of water, accordingly you want to change, maybe stop it, maybe open with the complete 100% throttle. Okay? Okay? Supplying of compressed gas. Take the example of rocketry engine. Okay, gasoline supplied to your turbofan engines. What are these? Continuous action. Understand? Here, I want to continuously monitor the temperature profile. Okay, and that profile should be reflected on HMI at my monitoring section. Clear? So that is a continuous or discrete? That's a continuous. But somewhere you want, now the controller has taken a decision. It is giving a command to actuator. Based on that, actuator, if earlier is open, now it is closed. Okay? If it has to open, now it will. So can it be treated as a discrete signal? Simple job, na? Simple job now. How many states we need? On or off? Open or closed? Do we need a complicated continuous signal? So can we avoid here? Because easier the step is, easier the control feature is. Clear? So certain actions you can control in a discrete manner. Certain actions you have to command in continuous, and then there are certain other parameters that may affect your finished product at the time of manufacturing or fabrication. but they are not directly involving. So the controller just want to continuously watch it. So controller means basically you are watching. That executive or that operator from HMI is watching. Okay, what is the external temperature value? Because you know that it regulates month to month, season to season. Yes, okay. So if it has to some abrupt condition, some abnormal condition, if it put some abnormal impact over the manufacturing process, then we regulate it. If not, then just keep on monitoring. Clear? So in process control, you need both the discrete and continuous system. Next, probably you are already aware, lump system. This is something we have been already classified under the head of somewhere network theory. So remember it is okay. So either you are defining lumped and discrete in terms of analog and discrete, or you are defining in terms of ordinary differential equation and the partial differential equation. It is up to you. One is the mathematical approach, one is the theoretical approach. You are free to classify in any. Yeah. Linear, stable, and the order of the system. Order of the system you all are very well aware. Okay? Probably till now you are also aware with the type of the system. Control theory is over. No? Control system is over. Right now you are. Okay? So probably you will be aware now with one term that is called the type of the system. Remember, order of the system and type of the system are two different things. Okay? Okay, till now you all are aware with the writing a transfer function of any model or any system, that means output by input, right? So the denominator equation, the denominator of the ratio, okay, how many roots are exist at the origin as far as the denominator roots are concerned. Okay, any transfer function is the ratio of numerator by denominator. Numerator can be some function, can be one, can be some function. Denominator can be some characteristic equation or not. So you just check that in denominator how many roots are exist at the origin. That is called the type of the system. Understand? It has nothing to do with the order of the system. When you say order of system, you expand all the fractions and then you check the highest order. Linearity, non-linearity is something we have been already discussed. So probably we can skip all these things. Okay. Let us take type of the dynamic process. What are these? One is called instantaneous process. Can you name any example of instantaneous process? Y is equal to k of x is an example of instantaneous process or not? Can it be or not? There's no blindly accept. If no, we should have a reason. If yes, we should have a reason. Can it be? Y of t is a function of time, is the response of a component, of experiment, of a device, of a system. X is some input, k is some proportionality constant, so we don't bother much about it. Somewhere it will vary between 0 to 1. Yes? But so y is proportional to x. Can I say that it is any process that can be mapped or regulate based on this simple equation? Can it be treated as an instantaneous process or not? If input is changing, output will change instantly or not? Yes? Then it is an example of instantaneous process. What is the order of the system? You check. Check. Now give some example. Achha, as far as this instantaneous process is concerned, you will come across two important terms under the head of control system. One is stability, one is gain. Now if x is increasing, y instantly increase. If x is decreasing, any action of x is proportionally responding to y. Okay? Or y is behaving with respect to any change experienced by the x. Anyway we can see, right? So what do you think, that the gain of such process will improve or the stability of such process will be high? Because you cannot control both. All you people have done series RLC tuning circuit, parallel RLC tuning circuit, huh? Number of times, no? No more magic. Let me repeat the same characteristic for your reference. Okay, something like this, है ना? So this y-axis is Q factor. You write Q factor, ना? है ना? X-axis is bandwidth. Is it? Is it? Let's say we have done something. We change the value, element value of RLC, and because of that, next time what happened? That this curve has been modified like this. Earlier is 1, here I am naming 2. You see? Can you see the clear difference in 2? Okay. Refer the curve 1. Can I identify plus minus 3 dB point? Let's say somewhere here. As an example I am taking. Okay? So it is plus 3 dB, it is minus 3 dB. So I can draw 2 dotted lines here. So this is my F1, this is my F2, within which I can easily control my device or system, which is operating based on this characteristic 1 profile. Are we correct? Now we have changed some actions, and because of that now the characteristic nature behavior has moved from 1 to 2. Okay, same setup, right? But maybe different combinations. Clear? So now what happened? Your Q factor is increased, no? Can I say that bandwidth has compressed? Yeah? Both are the same system. So Q multiply bandwidth is offering the same thing, same information, but the characteristics are different. Right? One is little sloping, one is very impulsive, relatively more impulsive. In one case, in characteristic 2 adopts higher rate of change as compared to characteristic 1. Can we say this? Or the characteristic 1 is offering wider bandwidth, okay, lower value of Q factor. Characteristic 2 is offering lower bandwidth, lesser bandwidth with higher Q factor. Everything is correct? Which one will offer you higher gain? What is gain? Again output by input, or anything else? Output by input. So which one will offer you higher gain? Q factor is gain. Understand? So sometimes for some application, if it is frequency scale, we write Q factor. If it is time scale, we write it strength, amplitude. Clear? Right? On a time scale, frequency scale, we write it gain, Q factor. So this one, I can write bandwidth. So do you think that bandwidth has any relation with the stability? Wider the bandwidth is, higher the stability you will get, better the stable system you will get. Lower the bandwidth is, lesser the stability you will get. Why so? Because in characteristic 2, due to this high rate of change, it doesn't matter higher rate of change or lower rate of change. Somewhere you will find your 3 dB bandwidth or not. As compared to maximum quotient value, you will get plus minus 3 dB point. Now let us redraw it. You see, where you have a more tolerance, where you have a more flexibility. Characteristic 1 or 2? 1. Why? Wider bandwidth. So if needed, 2 people together can enter through this room. If one side of the door is completely closed, then only one can come. What happens? Space को compress कर दिया ना आपने. So on a frequency plane, it is something like that. You have compressed the plane. Okay? So you increase the strength of the signal. Q factor increase किया, gain improve हो गया, bandwidth decreases. But in original characteristic, it offers wider bandwidth, therefore more stable system. But for that, you need to compromise with the gain. So decide. Okay? So depending on your application, either you can get higher bandwidth, that means more stable system with little bit compromise to the gain, or you can attain higher gain by compromising the stability, or I would say that at the cost of stability. Correct? And your two beautiful examples are always written there. Whenever you will have any confusion, just consider amplifier and oscillator, you will get your answer. Who offers better stability? Oscillator or amplifier? Oscillator. Because if it is tuned to operate at 1 megahertz, it will kept on operating at 1 megahertz until unless you will not stop energy supply. You stop power supply, machine will off, de-energized, right? Okay. So how the oscillator comes? It first started from entered to the overshoot zone, over damping, then it reached to the under damped, controlled damping. Okay, undamping is something different. You can't do anything. You want to under damp, perfectly under damp. Okay, as good as undamped zone. Okay, if you are operating at 100 hertz, means you will operate at 100 hertz. If you are operating at 1 megahertz, you will operate at 1 megahertz. Now you compare these two signals. Its the gain and stability will different or not? One is operating at 1 megahertz, one is operating at 100 hertz. One frequency is relatively very high as compared to the other. So do you think that the gain will same in both the cases? No, not possible. Right? So oscillator is providing a perfect stable signal because it is designed for that. Okay, then we don't look for gain. That's why we take a positive feedback. Getting my point? Because we are kept on supplying energy. In amplifiers, what it does? What it does? What is your goal? You want to amplify the signal. You are not bothering about the stability. Okay? Okay? Because the sensor has given an output at the range of 20 millivolt. 20 millivolt signal can't even travel 20 centimeters distance. How would you communicate to a longer distance? Okay, where the controller, that means, is kept around 1 kilometer away from the sensor, or HMI is kept around 500 meter or 5 kilometer away from the sensor. This I am talking about industrial environment, and things will become more and more challenging if you talk about. Okay, sir. If you talk about your mobile and cellular communication systems, understand? Clear? So in these scenarios, in amplifier, what is your goal? You says that okay, if I will be able to reach 12 millivolt signal, that would be more than sufficient to communicate my data from the field sensor to HMI. Okay? Now you need some tens of volt. What was the original signal? Tens of millivolt. How many times I need to amplify? 10 raised to 3, 4 times roughly. So what factor is more important to write to me? Stability of the signal or gain of the signal? Gain. So I want to amplify the signal at any cost. I will not bother about the stability. Now you will have to adopt the characteristic number 2. Clear? We will continue our next. Close.